Hello, my name is Kirubha, and I'll be sharing about my FYP on name entity recognition in the medical domain. This is the outline of the presentation. First, I'll be talking about the background issue, followed by the introduction, datasets and models, experimental results, followed by the deployment of the NER models, and the conclusion. The current problem is that there is an increasing workload on medical professionals. Firstly, for emergency first responders, there's a need to fill up callers' information and disseminate it quickly since it's time sensitive. Secondly, for doctors, they require time to read and analyze patients' history before diagnosing them. According to a report by SCDF, there are on average 585 calls every single day received in 2021. In addition, another research found that it takes 16 minutes per patient for a physician in the US to read up on electronic health records of a patient. Thus, there's a need to reduce time and information overload on these medical professionals. The objective of this project is firstly, to use name entity recognition to help emergency responders to automatically identify essential information from call transcripts and assist in auto-filling of forms to faster disseminate information. Secondly, doctors can benefit from this by using NER to automatically identify essential clinical entities such as the amount and type of a drug a patient has been taking to understand each patient faster. The scope of this project is to train and review models from general English domain to evaluate the best model and the best architecture, and then apply this knowledge to the medical domain on an emergency hotline dataset as well as a clinical dataset known as N2C2. Another objective is to create an application to deploy NER models from any domain. Next, for the datasets, the emergency dataset has 17 entities and around 39.4K training sentences, while the N2C2 dataset has 9 entities and 39.9K training sentences. A problem faced when cleaning and extracting data is that there are often missing entities in newly sampled data when sampling a subset from a main dataset. Thus, a new method to derive balanced samples was created with the aim to have at least one occurrence of each entity in the sampled data and maintain the overall distribution of entities. Through an improvised random sampling method, the idea is to sample a fixed percentage P from each class, and minority classes are sampled first. For example, this is the distribution of entities in an original dataset. The ones in red are the minority classes. When normal random sampling is used to sample 100 sentences from the dataset, the distribution of minorities becomes 0 and are missing from the sampled data. However, with the improvised random sampling, it can be observed that at least 2 occurrences of each entity are there, with the overall distribution of entities maintained as well. Thus, the improvised method is effective in obtaining well-balanced data samples. Next, a deep learning approach was taken through using BERT-based models, which are bidirectional encoder representations from transformers. It is a pre-trained model which can be fine-tuned on smaller datasets. There are a total of 5 BERT variants and 2 different architectures that were examined as well. As for the results on the emergency dataset, the macro F1 scores were all relatively high for all the BERT variants, and the best model is bioclinical BERT at a macro F1 of 0.9945. For the N2C2 dataset, the best model is MedBERT, which has a macro average score that is 1.71% higher than that of the BERT model. I will now be showing a demo of the Flask application that was developed to deploy NER models from any domain. This is the application developed through Flask called the NER Finder. So first there's a box for the user to input the sentences. So once the user inputs a sentence, let's say this one, they can click on Submit for the results. Or the user can choose to clear the input and redo or refresh the page instead. So once the user clicks on Submit, it will bring us to the result page, which shows the original data input and the result of the data with the identified entities in different color codes. This saves time by enabling the user to digest large amounts of information quickly and identify essential parts of the text. There's also an About tab, which shows information on the model that's being deployed as well as its entities. In conclusion, The best models were examined for 2 different medical datasets. Also, an improvised random sampling method and task application were introduced in this project. The relatively high accuracies for the medical NEM models indicate that they could potentially be used to save time for medical professionals and assist in streamlining their workflows. Thank you.